All right, it's recording. Okay. Oh, this is frozen. Not frozen. Okay. Hello, my name is Devin Austin. I'm a Pod 2 TA for Rehab, and I'm joined by Mr. iPad, Mr. Duncan T. Tulimieri, also Pod 2 TA, and we are back. Oh, would you like to say hi?
Yes, hello everybody.
Hello. This is our third video for
Hmm.
the week 5 activity. So just a video to accompany each homework assignment, and this is to accompany week 5. And if I were to bring up week 5. Let's share my screen. Boop. So the purpose of week 5 is to start loading in and manipulating data. And we do this from the point of view of loading in a specific CSV file, which is pretty common for data science. And then extracting it, indexing out specific data based on specific keywords that you'll input, and incorporating some NumPy functions, some that we played with last time, some new ones, like just some basic statistics like mean, median, standard deviation, all things you would use in your data analysis, and then some more advanced applications of NumPy. Will be pretty fun to get into. A lot of this uses the database pandas, which we'll get into, but pandas is a pretty common library you'll use to load in CSVs and manipulate and extract data. Am I missing anything?
I don't think so.
Okay. I also have the data repository up, so I can preview that.
Yeah.
So within the assignment, there is a link to the data set. There is, I believe, another way to load in the data set, but I would recommend this one just to make it so we're getting it in as a CSV, because that's the most common format we're going to see. So the link takes you to the UC Irvine Machine repository. You can just download the data set. And the Iris data set is a pretty common classic data science repository. You'll see it in some like Kaggle machine learning competitions, AI competitions. So we figured we'd use it for this since it's just so common and easy to work with. Yeah, just different types of petals or different types of flowers that are classified by sepal length, sepal width. I actually don't know what a sepal is, but that's outside my field.
Look it up. I think I know what it is. I think it's
Sepal,
like one kind of like leaf.
one leaf.
Oh no.
Sepal, sepal, sepals. Sepal, tiny leaf.
The innard part.
Yeah,
Where is it?
sepal,
Oh yeah, like the
little
little
leaf.
leaves that
Mhm.
come off.
So it classifies them by sepal length, sepal width, petal length, petal width, and different classes.
Hmm.
Cool.
Setosa, iris, etc.
Hmm. Cool. So at this point, I will turn it over to Duncan, where he will code because I am broken, but I will chime in and help code at the same time.
Not for long, and I think we'll bounce it back and forth between this doc and the VS Code.
Hmm.
All right, let's get it started. You see VS Code?
Hmm. Hmm.
Alrighty. Um, so we got to go to TA projects, 2024. Activating the environment that we created in that first one. What do we say? Week 5, right?
Week 5.
Got the data set here. You guys can see.
Hmm.
Um, okay, sweet. Let's create a file and let's get cooking. Wait. All right. What's number one? Loading the data, right?
Yep. Let's say you have the file, write a Python command to load the file using the pandas library.
All right. First thing we got to do, Import pandas.
Import pandas.
And what is it? Load CSV, is that right?
I believe so. pd.load CSV.
Breaking my rules already.
I was gonna say
Um,
PD, that's not panda.
yeah. No, I'm not breaking my rules. I take it back.
Spell it out every single time. Pandas.
Yeah, I think I need to pip install this. It's not giving me anything. Yeah, we just got NumPy. All right, I'll hit it with the old pip install.
Nice.
And then what do we think this is? File name?
Yep.
It's taking a while. I believe it's just
path?
gonna be, huh?
Your path name? Or might
Yeah.
just be path?
Well, albeit I'm running from week 5, so it should be able to just hit it with the iris.data. Let's see. I think that might be skipping ahead a bit.
Yeah, that's number 2.
Uh, 5. Load CSV, read CSV. Gross. There we go.
And then you jumped ahead with line 5, but the next part would be after loading the data set, write a command to display the first 5 rows of the data frame.
All right, let's slow it down a bit. So here we, first line, line 1, we import package pandas. Line 4 is what we use to take the CSV and put it into a data frame. And then line 7 is what will print out. The dot head is basically calling the pandas dot head function on the data for the asking for the print the first 5 rows. Is that a solid explanation, would you say, Dev?
Isn't there a way to print out the last 5 rows too? Is that just tail?
I don't know. Might be like foot or something.
Because this isn't a question, but I'm still curious.
Would you say tail?
Yes.
Ooh. Let's see. Nice.
Beginning and end.
Bad too. Nice.
I think we might go over this in like the main like discussion videos, but pandas reads things in as a data frame, which are very, very convenient. They're kind of like dictionaries with a series of associated tools, specifically used for manipulating data. Excuse me, like head and tail are functions built into a data frame that allow us to easily do this.
Dev, yeah, I see some, we got a little bit of an error here.
Ooh.
We got to, I believe we can specify
Yeah.
header.
Header, yep. And I don't know if it's because there's no header, or maybe let's just start with 0.
Header equals 0.
Yeah, let's see what happens.
That's what it defaulted to, looks like.
1. Okay, I'm getting worse.
I think we might need to specify our header numbers. We got header names. That's probably it.
Header names or column names?
I think it's just names.
And
The input after header.
does the data set not come with column names?
Apparently not. Just the CSV. It probably says in the docs. What did the docs say? Can you read me off the
You ready?
Yeah.
Blah, blah, blah. First, and these are all going to be lowercase and use spaces between the words. The first one's going to be sepal length.
I'm gonna replace it with underscores.
Okay.
Yep.
Sepal width.
Yep.
Petal width or petal length, sorry.
Did I spell that right? Patal.
Mm-hmm. Petal width. And class. Nice. And all of
Yeah,
these
there we go.
are what I'm getting from the link in the activity that brings you to the data set where we
And this
spent
is
a couple minutes talking about sepal length and figuring out what it was.
and this looks better too because we can see now we've got these column names, and we can see that our first entry, the 5.1, is what we had originally as column names. So this looks like it's working well. All right.
Do you know what the next question was?
Let's see it.
It was set the data frame column headers as detailed out in the repo and make sure you don't
Nice.
use any data.
It's almost like we made this. I'm gonna install black so I can format this properly.
Black is just a formatter to help format the document, just to make things a bit more clean and organized automatically. Beautiful.
All right.
Next. Boop, boop, boop.
Yes.
So there are some kind of conceptual ones in here and not really conceptual, but the next one is after loading the iris dataset into a pandas data frame, how would you index and print the first 10 rows of the dataset?
Ooh, I'd probably just do head 10.
Yeah. Can you do it?
What is it? Index and print first 10 rows?
Yeah.
Boom.
Nice. Can you do it without head?
Probably.
It's gonna index it like
Is that just like a matrix?
I don't think it's as easy as doing it like a matrix. I think that's why they made the head and tail
Yeah,
functions.
and we'd have to do the loc and iloc, and I think that's later, right?
Yeah, that comes later.
Yeah,
Let's do that head for now, and we'll come back to it with loc.
Yeah.
Next,
Hit me up.
write a command to extract only the sepal length column from the iris dataset using regular indexing.
What does that even mean?
Regular index, we go over it in our slides.
What did we say regular indexing was?
I'm looking up our slides right now. Not that
Oh,
bad.
I think I know what it is.
Presentations, week 5.
Yeah, I think that's looking good. Also, I'm just gonna start. I'm gonna comment out these prints so that we can keep it nice and clean.
Makes sense. Yep. Next one.
Hit me.
Suppose you want to retrieve rows 5 through 15 from the iris dataset. How would you use .iloc indexing to achieve this?
iloc for rows 5 to 15.
Yep.
For the whole data set.
Yep.
I think it's data.iloc and then this. That here. I think this, we said rows 5, so this is going to be 4 because indexing starts at 0 to 15.
Hmm.
And we want all the columns. Is that how iloc works?
I don't think so. I think it takes a specific command, but we'll see. Trial and error.
Whoa. Oh,
Oh, nice.
that's like a nice.
Oh, you got a 4 in there.
Yeah. Starts at 0, right?
Yeah, that's fifth. Yeah. Nice. Next.
1, 2, 3, 4, 5, 6. Yeah, because then 15 is 14. I gotta love the 0 indexing.
Yeah. The next one is a conceptual one. It's explain the meaning of the colon in the code you just used. We use colon twice.
What does the colon mean?
In the first instance of your colon, the 4:15.
Ooh, true.
We got two.
First instance. You want to explain? I'll write it out.
Yeah. So that essentially means you want to start your indexing at 4 and then continue the indexing all the way out to 15. So everything in between.
It's like get between
Get between.
starting number, or let's say left number, and right number. What about the second instance?
Second instance just means everything.
What do you
All
mean by everything?
all indices.
All
Values.
all of said dimension.
Yeah. Because this could go for rows or dimension.
Yeah, columns.
Columns. We just
Or
have it in
pages.
columns because it's rows by columns.
Mm-hmm.
Yeah.
Nice.
Ready?
Yeah, what are we looking at next?
Write a Python command to select the first two columns, so sepal length and sepal width, and all rows from the iris dataset.
Okay, this should be pretty easy. I'm going to use iLock again. And we're
Yeah.
getting the first two, so from 0 to 2, because it is exclusive and starts at 0. And all rows. So this is going to be colon and then 0 to 2. Is sepal length and width the first two?
Yeah.
Do we remember?
Yep.
So the length, width, yeah. Alrighty.
Let's see it. Nice. And scroll up.
We got all the rows, sepal length, sepal width.
Beautiful.
Very nice.
Next. Ready?
Yeah.
Use Boolean indexing to retrieve all rows from the iris dataset where the species is equal to iris setosa. Capital I.
Yeah, I'm gonna lean on you for that. Okay. Let me first comment this out. And now we're gonna get data. Let's go. I think it's not iLock anymore. I think it's just regular lock.
Just regular
for Boolean, yeah.
lock.
We want all rows were
All
for
rows.
iris setosa species. So then it's going to be data. You said this is class. This is going to be, what is it? What do we think? Capital iris.
Yep, let me double check. Huh.
Here,
Yeah, I think it's capital I. Yep. Rest
capital I, everything else lowercase.
Yep. Setosa.
That'll get us the right rows, and this should get us the columns. Got nothing else printed out. Nice.
What we want. Yeah.
That's pretty good.
Yeah, everything that's Iris Setosa.
Yeah, so here, this is the part that gets us, so the rows, because it's rows, comma, column, we want all of the columns, and then we only want rows that have the class Iris Setosa.
Mm-hmm.
Nice.
Easy peasy. Next, write a Python command to find and print all rows where the petal length is greater than 4.
Ooh. What is that, inches?
I think it's centimeters. Yeah, centimeters.
Centimeters. Okay. Yeah, no, that makes sense. We want all rows with the petal length. So same idea here. I think we did it like this.
Yep.
Greater than 4. All columns. Let's double check it.
Length.
Petal length.
Nice.
All those look more than 4.
Beautiful.
So this just another type of logical, just like this one.
Love it.
Awesome. Indexing is the name of the game.
Next.
What's that? Yes, next.
Using Boolean indexing, create a new data frame containing only the rows where the sepal length is less than 3.5.
New DF with rows where sepal is less than
Less than 3.5. This will be
2.5.
sepal width. Sorry.
Sepal width.
Yep, sepal width.
Okay. What do we want to call this? Small sepal widths.
Yeah. And this is useful if like you only want to work with a subset of the data set. So you don't want to have like load in everything every time. We just want a little bit to work with.
And we want to do this where data sepal width is less than 3.5. Out the head.
Is that sparkles, cake, and more sparkles?
I don't know why black does that, but
Nice.
it's kind of fun.
Sepal width, less than 3.5, 3.2. Nice.
Looking good. Not a lot.
Nice.
Just a couple there. Oh no, I printed out 5.
They got us.
We got ourselves.
We did.
Nice. Okay. Next one.
Next, we start messing around with NumPy a little bit. So convert the sepal length column from the Iris dataset into a NumPy array. Write a command to calculate the mean of this array.
All right. Loaded question. I like it. Okay. Sepal length. And is there a 2 numpy array for pandas?
I have no idea, but we can try something to figure it out.
Sepal length. Let's see if there's a.
I know if you do, maybe if it's values, it'll turn it to a list.
2 numpy.
Nice. What happened?
Numpy array.
Nice.
Now what do I have to do? Print the mean? And this should be as easy as just calling mean on it. I think that'll work.
Does that work?
No, it's a head work on what?
So NumPy is another package, but we didn't install NumPy. We're import NumPy.
Correct.
So it's just
Well, I think in pandas,
it's imported with pandas
yeah,
to be used with panda things.
yeah, we didn't import it into here,
Mhm.
but I think it comes out from pandas.
Pandas has so many tools.
Just using another one.
Ooh, ready for next one?
Yeah, I mean,
Write a Python command to calculate the median of the petal length column using NumPy.
median of, sorry, hit me again. Median.
Um, bu- 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 Median of the petal length column using NumPy.
That's all we wrote.
Yep.
I think we can even call a numpy function on it, but we're gonna have to import numpy.
Like from pandas.
No, like I think we can call numpy on it.
Oh
So
yeah.
like I think we can do this.
Petal length. Yeah. Hmm.
Looks about right.
Nice. Oh, easy peasy. Two more, and then we start getting into the more advanced NumPy.
Oh boy.
All right, this one is calculate the standard deviation of the sepal width using NumPy.
Sorry, I messed up.
What? Oh, oh, interesting. What are you?
Oh, Devin, keep talking while I do this.
Oh,
I don't embarrass myself.
oh. Um, talk about what?
Any jokes?
What was today's joke? Today's joke in the work block was less of a joke and more of a story because what was it? Yesterday I had a date and it was actually pretty perfect. And today I had a grape. And tomorrow I might have a raisin.
Very nice. All right, I'm back. We're back. We're back.
We're back.
All right, we're back.
You ready?
Yeah.
Calculate the standard deviation of the sepal width column using NumPy.
Standard deviation of
Sepal width.
sepal width using numpy.
NumPy.
So it should be pretty much exactly like the other one. With the STD.
Yep.
Sepal width. I just printed that up bracket by accident. 4-3, very nice.
Nice. Wait, how did you get the extra bracket?
I just I printed it and then I printed out with it.
Oh.
I typed it when I shut off.
All right, you ready for more NumPy?
Yeah, hit me.
Yeah. So, you sure you ready?
Yeah.
Convert the entire iris data set, excluding the species column, into a NumPy multi-dimensional array. That's part one.
Oh boy. Whole data set into ND array.
Yep, excluding
class.
species column.
Say it again without the class column.
Yep.
All right.
You want part two? We'll wait until after you get it.
Yeah, here, let's see what, I'm gonna rename this data df. It's gonna mess everything else up, but doesn't matter. Data NP. I think I can, what do you think, iloc or loc? think I'm gonna go with Loc. Just exclude the last one.
Isn't there a way
Borrowers.
to get it, or it's gonna be data underscore df,
Sure,
um,
sure.
where you can just remove the last column instead, everything except for the last column?
Without Loc, different way than Loc.
Isn't there like a pop? Or maybe that's for list.
You can pop a list. I don't know if you can pop one of these bad boys. Oh yeah, you could pop.
You can pop a data frame.
Pop item,
Hmm.
class, and then 2 numpy. This would be crazy.
Well, let's see if it works, and then we can talk about it to not just like write down random pop and numpy, just random noises.
Data not defined.
Data.
That's from somewhere else, I think.
17.
Oof. Come on. My keyboard's been lagging.
Mm,
I just did that.
Is it somewhere else?
Line 37. Yeah, it is. I knew I should have done that. Did it anyway.
I think that's all of them.
Oh, no, it just popped off the exact thing we didn't want.
What's the opposite of pop?
I don't know.
I don't know.
Do
Hmm.
you?
I thought pop was it
I
because
think opposite
in a
is just
list you
indexing.
can pop out.
Yeah, yeah.
um,
You pop one of the items out.
Yeah, but this
Yeah,
this pops an item out, just gets rid of everything else, and we want the
yeah.
exact opposite. All right, I guess let's just use iLoc,
I love.
or I guess we could use pop and just give it the right strings.
Yeah, that'd be gross. So I think I can do this. -2 should give us everyone besides the last one. Gross. That's not right. No, this is actually. Come on. Yes, -1. No. That should give us up to the second to last column, right?
Yeah.
There we go.
Huh? Why was it? Oh, because you had two colons. It was in
Yeah,
reverse.
I did the double colon. They reversed
Trying to
it.
be fancy, but it's a good time to
I
talk
know.
about the double colon. So double colon,
Mm-hmm.
let's flip the array, or flip whatever list you have, or flip whatever series you have.
Yeah, that's why when we were doing it, we saw the class first
Mm-hmm.
instead of last, which is where it was.
Mm-hmm. Mm-hmm. Nice. So now we have our matrix. You ready for part 2?
Yeah.
How would you verify the shape of this array?
I would call a shape on it. Do I need to?
Do you need to? No. Is it nice to show it? Yeah.
Verify shape.
Verify shape. I feel like it's
Bring
good data sets too.
data. I gotta get this bad boy back. Data np dot shape. (150 by 4). Very nice. Is that correct? Yeah.
Yeah. Yeah. Because there were 5 different categories. There are 5 different variables. Now there should be 4.
Yeah.
And if I go to the main page, 150 instances.
Perfect.
Next one.
Next one.
Create a 2D NumPy array that contains only the sepal length and sepal width. And then print the shape.
Create 2D numpy array.
Yep. Sepal length and sepal width.
Of sepal length and width. Okay. Let's name this sepal
Sepal data?
Nice, nice, nice.
Keeping it,
Data, huh?
keeping it simple.
Keeping it simple is right. Oh, actually, you know what we could probably do?
Hmm.
Yeah, just I think we might be able to do it like this. Simple length. What do you think this is gonna work?
Mm-hmm. Works like a dictionary, so should just give it the keys.
I just call ahead. Is that gonna give us 5?
Mm-hmm. Should default to 5. Oh, parentheses around the square brackets.
Key error. Yeah, let's try it. A list.
Or
I just made.
I think you need a
Oh, I think this does it in place.
and that's also sepal length. And on 58 we have sepal data.
I'm lost. So, what'd you say?
On line 58, we're creating sepal data.
Yep, and I call simple with.
Yeah.
You're right. You're right. Now I should be able to call ahead on it. There we go.
Nice. Blah blah blah.
Oh, I
And
have to
make it,
numpy it
yeah, numpy it.
to nump. And then no head, we gotta do this the old fashioned way. That should line up. Yep, 5, 1, 3, 5. Yep,
Nice.
there we
Next.
go.
Ready? Calculate the mean of each column in the 2D NumPy array that we just created.
Calculate mean of each column in numpy array we created.
Yep. In sepal data.
Data. That should be pretty easy if we do this right, which we're going to because we're going to use the dim argument. We should get how many values?
2.
Because there are 2 columns.
2 columns, as long as we specify the right dimension that we want to mean across or average across. Perform our function across.
I think I need to call this regular standard deviation.
Taking the mean.
It's mean. Oh my goodness, thank you.
Mhm.
Is it dim? Is it just not catching up?
I thought it was axis.
You're right. It is axis.
And this just specify row versus column versus however many dimensions we have.
Yeah. What do you want to do the calculation over? Oh yeah.
Nice. So that's will be
This.
average sepal length and width.
And so you want to explain why axis equals 0 gives us what we want?
So in the data frame sepal data, we have what 150 rows by 2 columns. And axis 0 is going to be the first dimension, and that will be the rows. So it's saying take the mean across all of the rows. If we were to change the axis to 1, it would say take the mean across each individual column. So we'd end up with 150 instances, which would be averaged across each instance's length and width, which we don't want that. Oh, what are you doing?
I was trying to I was gonna try to help you do the debugger, but it does not. I can't. I don't want to activate the environment. That's fine.
It's okay.
Just bash it. All right.
Good
Good explanation.
You ready?
Yeah.
I think these are the funner ones.
Here we go.
Create a 3D NumPy array where each dimension corresponds to one of the species. So a dimension for or classes: Iris setosa, Veriscolor, and Virginica.
Interesting.
And each dimension of the class should have a sepal length and sepal width for that species.
Okay, take the 3D NumPy array sepal data where each third dim corresponds to a class. So this needs to be a n by n by 3 because we have 3 different types.
Yeah.
All right. Wow.
150 by 2 by 3. 150 instances. And then we can have sepal length and width, and then class. We have 5 classes.
Let's try to this will be interesting here. I think I'm just gonna go at this just real basic. All first dim, all second dim for the first one. This is gonna be, oh, we have sepal data up here already, actually.
We just work with that.
Nah, but we don't have the class. That's okay. We can use our good old logical indexing skills. Is this yeah, this is lock or data df class. Can you tell me the types? What are they? Iris types?
Iris setosa.
Hold on. Iris, capital I, lowercase everything else. That's the convention they all follow.
Yep.
Okay, Iris setosa.
Next is going to be Iris. Versiccolor.
Versicolor, very cool.
Lowercase v.
True. Next
is going to start with Iris dash Virginica.
All right.
Yep.
NCA.
Let me double check. NICA or NICA.
VIRGNICA.
You need an I before and after the N.
VIRGINICA.
Yep. VIRGINICA.
All right, so this is going to equal the first iris type. And we want the columns. The first 2 columns, is that right? Sub length and width, yeah, first 2 columns.
Yeah. Sepal length and sepal width.
I don't know if this is gonna work. Can't do slice indexing on index with these indexers, so type hint. Ooh, boy.
So it doesn't like the 0 to 2.
Yeah, I think we have to do one of these at a time. So here I'll do it this way. Iris setosa. I'll just pull out each of the different datas.
Would it be fine with the Boolean indexing?
But
never mind. Let's just pull them out each individually.
Yeah.
Or if we have everything in a NumPy matrix, And we already, yeah, would it be easier just to do it as a NumPy matrix instead of data.df? We use our data.np and
I think, but do we
lock.
have class in there?
Um, no, but with the code that we have now, it should give us trues and falses. You get what I'm trying to put down?
You're trying to get the logical index from data df, but use data np.
Yeah.
Let's give it a shot. All right, data np indexing out. We want where data df class. This is what you're talking about.
We just want some rows and we just want some columns.
Like that.
Yep.
Data 3D not defined. I think I need to pre-allocate this. Thought this was a MATLAB thing.
We need to predefine a size too.
How do I do that?
But we can do mp.full.
Yeah, that's a better way to do it. It should just take size, right?
Nah, we want to fill it with something, and I typically fill it with nans. So the first thing I believe is going to be, what do you want to fill it with? I want to fill it with nans, and then the shape, which is going to be how do you want to do this? What dimension do you want first?
We know it's 150. Right.
Yep. Number of instances by sepal length and sepal width by the 3 different iris types. Does that work?
Well, in that multiple arguments.
Maybe not
Size?
shape, but size.
Got it. If I shape, is it not a tuple? Should I not give it a tuple?
There's no documentation for full. It's just
There's
that.
no documentation.
I'm gonna look up the documentation for it.
Yeah, please.
Okay. Let me do this with one hand. NP dot full. Oopsie, it's the wrong keyboard. NumPy. Oh. NumPy. Oh. Should be shape.
And then does it take a tuple?
I think it's shape first and then fill value.
Of course. Come on.
And do a fill value for the keyword or get rid of shape.
Not broadcast input array from shape 54 to 52. That is correct because I don't want all your columns data numpy. I want your first two. Could not broadcast from shape 50 to 2. That's right, because it isn't 150 is all of the instances, but this is divided by 3. Man, we're going crazy with the magic numbers right now. Not my best moment here.
Float cannot be interpreted as an integer.
Oh my goodness. I'm just going to do 50. Look at all those nans.
We'll fill them. We'll fill them.
Oh, shit, let's print. Crazy with this formatter. All right, and now I just have to do this for the other ones, yeah.
Yep, the other two. And this is kind of a interesting way of setting things up, but it's
That
being
I'm doing it.
for a reason. Yeah. Well, just the question itself to have all these in one big three-dimensional matrix.
Yeah. It's looking like I should probably toss that in a loop, but I don't think we've gone over that yet, have we?
I don't think so. Boom, boom, 1, 2,
Data 3D3. Oh, it's because this
0, 1, 2
indexing doesn't start at 1.
starts at 0 because we need to know where we come from. Start at the beginning.
0 is nothing. Yes, I just did this.
And we all start from nothing and then boom. Nice.
Looking good so far, I'd say.
All the nans are full.
Yeah, no more nans in there.
My names. You ready for the next one?
Yeah. How far along are we?
We're almost done, actually.
Oh my goodness. Okay, hit me.
2 more. The last one might take a bit more time, but this next one should be pretty easy.
Let's do it.
Calculate the mean and standard deviation of the petal length for each species in the dataset using pandas and NumPy.
I assume I'm supposed to be using Data 3D here.
Yeah, but the assignment says petal length. So
And that's what we didn't get.
yeah, that's what we didn't
That's not what
get.
they did. Okay, that's fine. I'm not going to use Data 3D then because I don't want to. Mean and standard deviation of petal length for each species. Let's do a little printf on this. What do you say? We got the types up here. All right, let's iris setosa. Petal length. And then we'll go with mean.
Yep.
And standard deviation.
Nice.
Right. And then let's do data df. And I want
Yep.
petal length. And I'm going to index only the where data, df, where the class is iris setosa. And then I want to take the mean of that. I don't know if that's going to work. See what happens. Failed to reformat. Uh-oh. That's not a good sign. Yeah, what did I forget here?
Or does all of that need to be wrapped? No.
No, I think this is because this is okay. So we're gonna get rid of this. I don't think this is gonna help. Yeah, it's not gonna help.
A different way for this to go too, but we'll do this first.
Say it again.
There's also another way you can do this a bit differently, where you can take a data frame and then have it automatically be adjusted using a group by function.
You want to do that? You want to explain it to me?
I don't know it off the top of my head. I just know there's a group by because I left myself a hint in this that says group the data frame by the species column. then apply
Yeah.
the statistical functions.
That makes sense. Okay, let's do iris setosa data, and we'll get all the stuff out. We'll get try it out here where we're not in the F print. And now what is this? Data DF class.
But I think you can just, well,
Oh no.
I think you can just do data underscore df dot group by.
All right, let's do it your way. My way is failing. Data DF and then just group by.
Dot group by. And then you give it what you want it to group by.
Okay.
Should be class.
Like as a string.
Mm-hmm. I think the keyword for it is by, but let's see what happens.
Oh boy. This is exciting.
Messing with pandas. Did it change anything?
No, this
Or did it just order it?
it just ordered it.
Mm. What's the next thing I did?
I guess then I could pull out 0 to 50, 50 to 99, 50 to 100.
I think do. Yeah. I think we can do that as well.
And then you want me to index out from here?
Sure. I didn't know where I was going with it. I just know you could buy, and I'm like, let's see what happens next. I thought it would be cooler. It was not. This was all that happened. It just sorted it for us.
Yeah, well then we can do it's gonna be all rows. No, we want 0 to 50 exclusive. All columns. Iris. Color. And then this is gonna be 50 to 100.
Maybe. Trying to look at your numbers. 54. I don't know if it's split exactly 0 to 50, 0 to 50, 50 to 100.
Pretty sure it is, if I remember correctly.
Oh yeah, because that's split right there.
And then let's look at this. These bad boys. Oh, it's been a while since I've do DFs have shape?
Thought it might be size. It's either one of the two.
Cannot subset columns with a tuple. Use a list instead. What are you talking about? Doesn't like my group by.
Doesn't like your group by.
I think I have to do the work on it. Because you just can't normally index on DFs, can you? Data frame group by has no loc. Oh.
You want to try a different way instead of the group by?
Yeah. You read my mind. All right, let's petal length class. Let's just get those.
Get all the petal lengths. And then we can get some Boolean indexing for each different type.
Yeah. Data DF and Gonna take all the rows. Question.
Thank you.
I don't like this, is it?
We're using iLock.
Is I like the right one?
I thought we would just get the column with iLock. Right. Or lock is just the column. iLock is going to be the numbers themselves.
I think lock is for Boolean index and lock is for all the other ones.
So we're getting all of the rows and we're getting which column?
Yeah, we want the petal length in the class. So that's 0, 1, 2, and the last one. I don't think it's gonna like this.
Trial and error.
Gross.
Oh,
I know. Oh,
oh.
they didn't like it. My keyboard is lagging like crazy right now. I thought I just charged it.
Nice.
Okay, we got petal length in class.
Mm-hmm.
Now let's pull out. Actually, I think we can then just probably jump right into this. We can look out where petal length class. Oh no, it's not gonna like that. The F statements don't like the square brackets in them. It's okay. Let's go. What is it? Iris Setosa. Petal length.
Mm-hmm. Not lock. And then just name.
I can just hopefully just call the on that. What do you think?
Did it work?
No, I was wondering. Oh my god.
Whoa.
I gotta give it the and we just want 0. Oh,
Okay, data lock.
yikes. We were cooking before.
What does the 0 do for 74?
0th column should be petal length.
Mm-hmm. What happens when you run it now?
Still get this.
And we can't debug, huh?
We use our brains to debug Dev. Iris Setosa petal length. So let's see what we got here. Key error 0.
There is no such thing as a 0.
Okay. And now what happens if I say just give me all 0?
It didn't work.
Uh,
Dot with regular, just dot me.
Did not like this.
Mm,
Slice not. What are you? What is going on here? Oh, is this just one dimensional?
dot size.
Oh my god. Yeah. What?
Huh. Um.
And it
hmm.
didn't like that. Okay. This is fine. Um,
Can I try one thing?
yeah, what is it?
Bu- 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 bu-
I was just gonna make another species DF and then use the 2 different DFs.
Another species, DF.
Yeah.
Okay, let's try it. All data frames.
Not the biggest fan of pandas, I'm not gonna lie.
It has its pros and cons. I think it's nice when you're learning because it has a lot of like useful tools and things. It does a lot of the heavy lifting behind the scenes, and it has a lot of useful functions like mean, standard deviation, things like that. Or if you wanted to load in a CSV, it's very convenient because you can do it in one line. There are other ways to do it, which are a bit more tedious and take more time to set up. And Panda just does it automatically inside, which is very, very nice.
Okay.
It liked it. But can we take the mean?
Of course. Gross.
Nice. Mean standard deviation.
Oh, let's round it off. I always go 0.2F. I don't know why. I'm just like 2 decimal places is
I feel like
superior.
that's pretty common, right?
You think so?
I always go 3.
3.
I always go 3.
I always go 2 or 4. Maybe odd numbers scare me.
Yeah.
What's the Setosa semicolor and then Virginica?
Versicolor?
Versicolor, not semicolor.
EER.
Versicolor.
Mhm. And then Virginica. Yeah.
Versicolor.
Versicolor.
Unica.
Ooh. Oh, goodness.
Versicolor. This is wrong. Can you check my spelling as I'm going through this?
Versicolor. You should do the alt.
Never.
What do you mean? You gotta write the same thing.
When I can type this fast, absolutely not. Would rather practice.
Alright.
You do have a point though, because it is lagging pretty hard right now.
Virginica. Yeah. Dos más.
Oh, that's not right. That is right. Oh,
I think you have one extra I
where? This
in
one?
front of the G. Virginica. Yeah.
Man.
Nan. Nice.
Ooh.
There should be no missing data, so I don't know how that Nan got there.
Uh-oh.
Let's figure it out.
You don't want to just do a man mean?
You should never just do Nan mean without understanding
Ah,
why there are Nans.
so smart, Devin.
Thank you. It's like I've been here
On
before.
Virginica. Ooh. I spelled that wrong.
Yep. Virginica.
There we go.
I should have checked your spelling.
Yeah.
So I'll share the blame. Nice.
Boom.
Cool.
Wow, that took us a while.
Because the other ones didn't take as long.
I know. Is that the last one or is there more?
That's the last one for week 5.
Oh, thank goodness.
That wasn't too bad.
That was not too bad. But that boy, oh boy, that last question, we really are poor students.
You just wanted to try a couple different things.
We did. We want to give them a challenge.
Cool.
And
So that was
Devin
week
made this
5.
one, by the way, everybody. Just like
I did. I did make that one, and then I think both of us made the rest, and then I twisted them
Yeah.
and made them a bit more complex.
Yeah.
Yeah,
It's good though. They're for exercises, extra practice.
they're good exercises. Let me share my screen so I can preview next week's.
Yeah, good call. Good call.
I think you started this one, then I twisted it because you got the gray
Yeah.
back.
Yeah. Can't
Um,
deal with the white back.
in week 6, we start getting through different for loops, while
Oh
loops,
yeah.
different conditional statements, even nested if statements, and we go through match cases, and advanced conditionals, and advanced loops. This is where I started getting a little crazy, so there might be another long one in there.
Another hour and a half, maybe.
Mm-hmm.
No props. I see Fizzbuzz again.
Oh yeah,
Fizzbuzz.
except there is one nested if statement. I remember this.
Very nice.
Why doesn't this just say 3?
3.
I'll figure this out by the time we.
Okay.
Okay. So that's
Awesome.
week 5. This is week 6. Thank you for joining us for this week's assignment. We look forward to next week.
Let's wave them goodbye.
Goodbye. Oh, my camera's over here. Bye.
I thought you were gonna do the other side.
So